SysML v2 Lesson 6 The Blueprint, or Defining Parts. In theory, SysML v1 always supported separating definitions from usages. A block provided the definition, while a part property provided the usage. However, in practice, the block became the universal hammer. Hardware? Block. Software? Block. Abstract logical concept? Block. To define a system structure, engineers used block definition diagrams. While composition could be shown neatly inside a block's parts compartment, many heavily relied on drawing graphical lines with solid black diamonds. As systems grew from 10 blocks to 10,000 blocks, these graphical BDDs predictably turned into unmanageable spiderwebs of crossing lines. SysML v2 solves this by introducing a formally standardized textual syntax alongside its graphical notation. Instead of defining the system as a block, we now use the partDef keyword for definitions and part for usages. This allows engineers to build clean, deeply nested structural hierarchies directly in text without being forced to rely on drawing graphical lines. So, how exactly does SysML v2 change our approach? It relies heavily on a reusable blueprint known as a part definition, or partDef. This doesn't represent a specific physical object sitting on a table in the lab. It represents the type or design of that object. It operates on two powerful levels. Number one, it can act as a black box by specifying externally visible features such as input parameters, output parameters, ports, and connections. Think of this as defining exactly what a drone connects to on the outside. Number two, however, it can also define its internal structure by specifying owned part usages and their connections, essentially listing exactly what specific parts live inside that drone. A great real-world analogy is a CAD file for a specific type of wheel. That CAD file is the partDef, or the blueprint. You only design it once. However, when you build a car, you will pull from that single blueprint to instantiate 4 specific physical wheels using part usages. Think of it like object-oriented programming. Java class represents the partDef, and the variables inside represent the part usages. SysML v2 elevates this to a universal pattern across the entire language, allowing a usage to be deeply nested and explicitly redefined for highly specific contexts. Example: let's build the physical architecture for our Skyzer drone. With this code, we are defining the structural blueprint for the Skyzer drone. Here's what's really happening. partDef, or definition, is defining the blueprints. We defined payload and Skyzer drone as definitions, or types. Because these are reusable blueprints, we can now create hundreds of different specific drones or payloads from these baseline structures without ever redrawing them. Attribute or properties. To define the physical properties of the blueprints, like their weight, we use the attribute keyword. SysML v2 replaced v1's value properties with attribute. By using ISQ mass value, we leverage the standard library for physics, International System of Quantities. The system understands the quantity kind, which is mass, rather than just a raw number. Now, if we take a closer look at the code, we will see that inside the Skyzer drone definition, we nested part payload, payload, and part flight computer, flight control computer. The keyword part indicates a usage. We are stating structurally that every built Skyzer drone must contain a payload. Because we did not specify a multiplicity, this system defaults to exactly 1. Now, for asserting constraints and making it a mandatory system law, we write a simple Boolean math expression, which is payload.mass will be less than total mass, and use the assert keyword. By doing this, we are essentially saying that if a payload's mass ever exceeds the total mass limit, this system architecture is immediately mathematically invalid. The parts tree, or hierarchy. In SysML v1, engineers often defined hierarchy on block definition diagrams by manually drawing composition lines connecting blocks. While SysML v1 offered a way to reduce this clutter by listing components textually inside a block's parts compartment, the primary interface for many engineers remained the graphical canvas. In SysML v2, you establish composite ownership directly in the code by declaring a part inside the curly braces of its parent definition, SysModeler. When rendered, the tool auto-generates a clean hierarchical tree from the SysModeler down to its parts, graphically showing both payload and the flight control computer nested inside SysModeler definition. To wrap up, the biggest takeaway is that we are evolving beyond the universal block. In v2, the textual syntax makes the separation between definition and usage universally explicit. We use part_def to create reusable blueprints, and we nest the part keyword directly inside those curly braces to define composite roles natively in the text. Add in inline asserted constraints, and we seamlessly shift from a graphical-first interface to a clean, strictly typed mathematical hierarchy. Next lesson, we will tackle composition and subsetting. How do we handle complex hierarchies like part car engine subsets engines? We will learn how to build precise product trees without the graphical clutter.